Hey everyone, and welcome. Today we're going to dive into a pretty wild topic, the invisible world of interference. We're talking about those unseen forces that can take a perfectly good IT system and turn it into an absolute troubleshooting nightmare. Let's get into it.
So just so you know, what we're covering today is actually the first part of a whole 10-part series. It's all based on a really detailed report called An Introduction to Radio Frequency Interference, or RFI, Electromagnetic Interference, or EMI, and Space Weather for IT Professionals. It comes from the pros over at RFI Detectives, who are part of Virtualization Options, LLC. In this first part, we're really just laying the essential groundwork.
So let me ask you something. Does this sound familiar? You're chasing down a network drop, a weird performance glitch, and just when you think you've got it, poof, it's gone. The logs look fine, the hardware checks out, but what if the real culprit wasn't in your switch or your server, but literally in the air all around them?
All right, so let's start by unmasking that ghost in the machine. The very first suspect we need to get a handle on is called radio frequency interference, or RFI. This is the prime cause of so many of those maddening intermittent wireless problems. You know, the absolute best way to think about RFI is to imagine it's the wireless version of electrical noise on a data cable. It's basically just unwanted energy that's shouting over the signal your devices are trying to listen to, and that causes errors, slowdowns, and, yeah, even dropped connections.
Now, some RFI comes from devices that are supposed to be transmitting energy. You know, things like your neighbor's Wi-Fi, the Bluetooth speakers in the office, even the microwave oven in the break room, which, by the way, operates right smack in the 2.4 gigahertz Wi-Fi band. These are all what we call intentional transmitters that can totally, accidentally interfere with your systems.
And then you've got the really surprising stuff, the unintentional sources. These just go to show how electromagnetically noisy our world has become. We're talking about devices that were never meant to be radios, but still pump out RF energy as a side effect. Things like cheap power supplies, some LED lights, and oh man, this is a big one. USB 3.0 hubs can fill your office or data center with a shocking amount of disruptive noise.
Now, if you've got any kind of networking background, this analogy is going to click instantly. Remember old Ethernet hubs? When two devices tried to talk at the same time, you got a collision. Well, RFI is the exact same concept. When your Wi-Fi signal and some interfering signal hit your device's antenna at the same time, that's an RF collision. And just like before, it forces your device to retransmit, which absolutely tanks your performance.
Okay, so we've got RFI down. And this is a big but. It's just one piece of a much larger puzzle. To really understand what's going on, we need to zoom out and talk about its parent category, electromagnetic interference, or EMI.
Right, and this is where things get really interesting. We've been talking about problems that fly through the air, but what about the problems that travel along the wires themselves?
So here's the deal. EMI is the big umbrella term. It absolutely includes RFI, but it also covers interference that is conducted. And that's the key word. It means the noise physically travels along conductors like your power cables or even your network cables.
Okay, so RFI, EMI. How do you actually tell them apart in the real world? Let's break down the practical difference, because this is what really matters for an IT professional.
It's actually pretty simple when you see it side by side. On the left, you've got RFI. That's your radiated through the air problem. Think of the classic example, a microwave oven messing with your Wi-Fi. But on the right, you have EMI. That's the bigger category that includes RFI and the conducted problems. The perfect example here is a network switch that starts throwing errors every time a big HVAC compressor on the same power circuit kicks on, dumping electrical noise right into its power supply.
Let's just walk through that exact scenario. That big motor starts up, right? It injects a bunch of electrical noise onto the power line. That noise travels directly into a nearby network switch, and bam! All of a sudden you're seeing bit errors on a port. You might blame the cable, you might blame the switch itself, but the real cause is conducted EMI from a totally separate system.
Okay, so I know this might feel a little theoretical, but what does it actually mean for you day-to-day on the job? Well, it means that a whole category of incredibly frustrating problems might have a cause you weren't even thinking about.
I'm willing to bet you have seen these exact symptoms before. CRC errors, links that flap up and down for no reason, weird packet loss, and even devices that just reboot randomly. See, these aren't always just networking problems. They can be symptoms of an electromagnetic issue. The next time you see them, instead of just thinking, bad cable or buggy driver, you can now ask yourself, hey, what else is plugged in nearby? What's on the same power circuit?
And really, if you remember just one thing from all of this, let it be this. Your systems do not exist in electromagnetic isolation. Every single piece of equipment you manage is constantly swimming in an invisible sea of electromagnetic energy, and all of it has an effect.
So think about it. We've just seen how a small appliance in your office can cause some serious havoc. That brings us to one final huge question. If that's what a microwave oven can do, what happens to our entire global communications network when the source of interference is 93 million miles away? We are, of course, talking about the sun, and we'll tackle that in our next explainer on space weather. See you then.